So in this video, we're going to look at how you can work out square numbers, cube numbers, square roots and cube roots, and also have a look at prime numbers and composite numbers. So for square numbers, a square number is a number created when another number is multiplied by itself. So the easiest way to look at this is if we work through here. So this little 2 here tells you have a square number. This is an index number, sometimes called an order or a power, and it tells you how many times this number 4 is being multiplied by itself. So 4 squared, as an equation, would look like this. It would be 4 times 4, and 4 times 4 equals 16. 16 is your square number, so this is your square number here. The biggest mistake people make here is they do 4 times 2 and get 8. That would not be correct. This is not timesing by 2. This is timesing the number 4 by itself. So another example, so 10 squared would be 10 times 10, which is equal to 100. Now, square numbers, you can arrange, if you had counters, for example, you could arrange them to make a square. That's why they're called square numbers. So 4 squared, you could have 4 counters, and you would have 4 rows of 4 counters. So if I just draw this quickly, and this would be a square. Not very well demonstrated here because I haven't spaced them out properly, but you have a 4 by 4 square. Okay, so 4 counters high by 4 counters wide. And that is how you know you have a square number. Now, coming down, we're going to have a look at square roots. So with a square root, just bring this down. This is the symbol you will see for a square root here. Now, sometimes it might have a little 2 above it here, but not always, okay? So when they're asking you for the square root of a number, the number inside, you want to know what number multiplied by itself would be 9. So in this case, the square root of 9, you would know would be 3, okay? Because 3 times 3 will give you 9. So the square root of 9 is 3. Going forward now, we're going to go and have a look at cube numbers. So cube numbers, instead of having the little 2, they have the little 3 here. So this tells you that 4 is being multiplied by itself 3 times. So we would write this as 4 times 4 times 4. And 4 times 4 is 16. And 16 times 4 is 64. Okay, so that's there. And a cube number is called a cube number because if I roughly draw a cube here, so cube is a 3D shape that has 6 equal faces, and all of the edges in a cube are the same length. And it's called a cube number because you could make a cube. So this would be a 4 by 4 by 4 centimeter cube, which would have a volume of 64 centimeters cubed. So we haven't necessarily covered area and volume yet, but that's another, those are other topics that use the squared and cubed. And coming down here for your cube root, it's the same sign as the square root, but it will always have the little 3 here. So the cube root of 64, 64 is created by 4 times 4 times 4. So the cube root of 64 will equal 4. Coming down now to look at prime numbers. Now, prime numbers are important numbers. They're basically the building blocks of all numbers. And later on, we will be looking at how to find prime factors of a number as well. To identify whether a number is prime, you need to remember the following things. So the first thing you need to remember is all prime numbers have only got 2 factors. Okay, so they have only got 2 factors. 1 and themselves. Okay, so they are 1 and itself will be the only factors of a prime number. Okay, so all prime numbers have only 2 factors, 1 and itself. And for that reason, 1 is not a prime number. 1 has only got 1 factor, so it is not a prime number. Your smallest prime number is 2. Okay, so it's 2 because 2 can only be divided by 1 and 2. The smallest prime number is 2, and 2 is also the only even prime number. Okay, so 2 is the only even prime number, and the reason for that is that all other even numbers can be divided by 2. So therefore, 2 is your only prime number, your only even prime number. All other prime numbers are odd. Okay, so all other prime numbers will be odd, but that does not mean that all odd numbers are prime. So in order to investigate whether a number is prime or not, if we're dealing with numbers up to about 140, you can ask yourself 4 questions. Okay, so the 4 questions you can ask are, can I divide by 2, divide by 3, divide by 5, or divide by 7? So if the answer to all 4 of those questions is no, you can quite confidently assume you have a prime number. So if we look at 13, for example, can we divide it by 2? No, because it's an odd number. Can we divide by 3? Now, there's a quick test to test if a number is divisible by 3, and we can do that by adding the digits. If you add the digits and they come to a number in the 3 times table, you can divide by 3. So when we add the digits in 13, it comes to 4. So we know it cannot be divided by 2. It cannot be divided by 3. The next question, can we divide by 5? Well, to be divisible by 5, the number would have to end in a 5 or 0. So this ends in a 3, so the answer is no. Can we divide by 7? There's no kind of tricks for 7. You have to just go through the 7 times table, and we go 7, 14, so 30. So 7 goes into 14. So we know that 7 cannot be divided, will not divide into 13 exactly. Therefore, we know that 13 is indeed prime. So let me just get rid of those other little scribbles I've got on there. Okay, so the next number we're looking at is 54. Well, it's even, so therefore we know it cannot be prime. 37, so can we divide by 2? The answer again is no. So we'll put a little cross here. Can we divide by 3? Well, 3 plus 7 is 10, so the answer to that is no. Can we divide by 5? Doesn't end in a 5 or 0, so it's a no. Can we divide by 7? Well, 5 times 7 is 35, so therefore 7 would not be divisible, would not divide into 37. So we know, we know that this is indeed prime. Okay, so we can circle 37. 96, now that's even, so we know that that is definitely not prime, so we can get rid of that one. 89, again, you can divide by 2. It's odd, so that doesn't work. Divide by 3. 8 plus 9 is 17, which isn't in the 3 times table. Divide by 5. Doesn't end in a 5 or 0. Divide by 7. Well, 7 times 12 is 84. So you know, therefore, that 89 is prime. Looking at 45, we can't divide by 2 because it's odd. We can divide by 3 because 4 plus 5 equals 9, and 9 is in the 3 times table. So therefore, 45 is not prime. So that's the kind of investigation you can do. With numbers greater than 140, you may need to start looking at dividing by 11, 13, 17, so slightly bigger prime numbers. All of these numbers here are prime numbers in themselves, okay? So we can use these to test, but usually numbers up to about 140 and questions you would get in the 11 plus, checking if they can be divided by these first 4 numbers is usually enough to get you started. Now, a composite number is what we call a number that isn't prime. So any number that isn't prime is called a composite number. So for example, 10 would be a composite number, 36 would, 69 would. All of these numbers here would be composite because they are not prime.